So in question 3b, we're given a loudspeaker emitting a sound of frequency 210 Hz into a pipe that is as shown on the diagram. We're asked to outline how the standing wave is formed in the pipe. And well, the general idea we need to have here is that the loudspeaker is emitting sound waves, which are moving through the air, and these sound waves are reflecting at the end of the pipe. At end of pipe. And what happens is that these reflected waves are interfering. They superpose with the other incoming waves coming from the opposite directions, and these two waves will interfere. And so these interfere with the incoming waves. And then in part 2, we need to determine the wavelength of the sound. So what we see here is that what we have already drawn, they have already drawn the wave for us. So what we see here, there's a 3/4 of a wavelength. We would draw one more fourth and we would have a complete wavelength. So we can say that L is equal to 3/4 lambda. We can rearrange for lambda. As we know, the length is 1.2 meters. So lambda will be 1.6 meters. And then in part 3, we need to determine the speed of the wave in the pipe. So we know the frequency of it, we know the wavelength of it. V is simply equal to F times lambda. So 210 times 1.6 will give us 340 meters per second.